DNA is DEC's means Digital Equipment Corporation's digital network architecture and is announced in 1974. The products that implement DNA are referred to as DECnet products. The term DECnet is used loosely to describe the family of products that operate within the DNA model. DNA maps better with OSI communications, networking, and services. And because DNA maps so closely to OSI model, we are going to explore DNA's 7-layer implementation. Here is a brief summary of key DNA protocols. Ethernet version 2. Ethernet version 2 was first co-developed by Digital, Intel and Xerox as version 1 of Ethernet specification, that is a 10 Mbps physical and data link layer protocol. It was based on existing 3 Mbps Xerox Research Ethernet. Ethernet version 2 uses CSMA/CD and Manchester encoding and was originally developed using coaxial cable. The Ethernet version 2 specification is very similar to the ISO 802.x. However, the Ethernet version 2 frame format is slightly different from the ISO frame format. High level data link control, that is HDLC. HDLC is a data link layer protocol which supports both asynchronous and synchronous transmission synchronization using physical layer modem protocols. HDLC defines both the format of data frames as well as the command syntax to establish frame transfer. Using the defined commands, HDLC can also achieve LLC level flow control. Digital Data Communications Message Protocol, that is DDCMP. DDCMP was the original DNA data link protocol designed in 1974 for WAN links. Like HDLC, DDCMP can operate with synchronous or asynchronous transmissions. It can also be used with full or half duplex, point-to-point or multi-point configurations. DDCMP uses commands and acknowledgements to provide connection-oriented error control, LLC level flow control, and message sequencing services. Connectionless mode network service, that is CLNS. CLNS is supported at network layer of DNA. DNA supports both CLNS, that is connectionless, and CONS, that is connection oriented network services. CLNS use 3 ISO protocols and they are 1. ISO 8473, a protocol for providing the connectionless mode network service. which controls data transmission tasks between two end systems. Second is ISO 9542, end system to intermediate system routing exchange protocol for providing the connectionless mode network service, which is used to perform routing functions. And third is ISO 10589, intermediate system to intermediate system intra-domain routing exchange protocol for use in conjunction with the protocol for providing the connectionless mode network service, which defines the mechanisms for moving data packets between routers. Since these protocols provide connectionless service, they are limited to performing addressing, switching, route discovery, and route selection tasks. Connection Mode Network Service, that is CONS. CONS is supported by DNA through two protocols. One, ISO 8208, a X.25 packet level protocol for data terminal equipment, and is the ISO version of X.25. And second is ISO 8878, which use X.25 to provide full connection oriented services. ISO 8073, connection oriented transport protocol specification, and is used by provide a reliable connection at transport layer. Implementation of this protocol determines the level of flow, error, and packet sequence control provided by the network. Network Services Protocol, that is NSP. NSP was designed by DEC for DNA and has been a part of DNA since its announcement in mid 1970s. NSP offers a connection-oriented, flow-controlled service through normal or expedited full duplex subchannels. To achieve end-to-end flow control, the network layer reports congestion to the transmitting NSP, which reduces the number of outstanding messages it will tolerate using either the guaranteed rate or window flow control method. Session control. Session control provides an interface between applications and the transport layer protocols. Session control is a proprietary architecture that performs the following functions: 1. Address to name resolution. 2. Protocol stack selection. 3. Transport connection management. And 4th is connection identifier addressing. ISO 8327, Session Protocol Specification, which implements the service definition found in ISO 8326, a session service definition. ISO 8327 provides negotiated connection establishment and release as well as half duplex data transfer. In addition, the protocol can use one or more transport layer connections for each session. It organizes data transfer by synchronizing the transfer of packets through major and minor synchronization tokens. Using tokens, a session's dialog can be reset to any synchronization point. Abstract syntax notation character code translation scheme, that is ASN.1. ASN.1 uses BER, that is basic encoding rules, to translate to and from ASN.1 notations. ASN.1 can perform character code translation. FTAM, a generic file transfer, access and management protocol. A DNA application that provides file transfer and management capabilities in coordination with DAP, that is Data Access Protocol. DAP enhances FTAM by providing file retrieval, storage creation, deletion, and renaming functions. It also supports heterogeneous file systems and allows multiple access to the same remote file. FTAM and DAP also supports database indexing. NVTS, a generic network virtual terminal service. A DNA application that provides terminal emulation through remote operation service availability. Using NVTS, data can be translated from the local terminal format to the network terminal format before it's transmitted to the host. This process ensures that heterogeneous systems can communicate effortlessly. Mailbus product family and X.400 message handling system. Mailbus is a family of proprietary email services developed by DEC. Mailbus products use the X.400 recommendation to interact with other X.400 implementations on an internetwork. Naming service and X.500 directory. This is the portion of DNA that performs address to name resolutions. X.500 is a directory service recommendation.